Hi, everybody. My name is Robert McLean. We're going to be starting the webinar in about a minute. Just going to give people a few more seconds to join. So we'll be with you in just a moment. Okay, so hopefully that'll be enough time there. My name, as I said, is Robert McLean. I cover real estate for the website the Prime. It's a real pleasure to be back again with a fascinating group of prop tech entrepreneurs who have formed an alliance serving the needs of owners and managers of critical infrastructure. Together, they're making it possible to create a digital twin of huge, complex structures such as runways, dams, and bridges. Digital twins, as many of you will know, are used in a variety of different fields, including the health sector, manufacturing, and machinery. The idea in this case is to have a digital model of major pieces of infrastructure in order to enable more efficient monitoring and maintenance. But it's also to help deal with the potential consequences in the case of some type of catastrophic failure. We've got two of the members of this alliance, Carl Pucci of EO59 and Martin Rappos of Ocular.
Hello.
Hello.
How are you guys doing? So, Martin, maybe we could start with you. You could tell me, or you could give us a bit of an idea of how your company Ocular is using the power of what you guys focus on, which is augmented reality, to enable the better monitoring of pieces of critical infrastructure, and how you're able to help create a digital twin of these huge and very important structures.
Yeah, thank you very much. Yeah, thanks, Robert, for the introduction. My name is Martin Rappos. I'm the CEO of Ocular. We started Ocular 4 years ago in the US, in Virginia, as a visualization company. And we started indeed with augmented reality, with AR. But over the years, we actually figured out that by being able to quickly convert any kind of 2D or 3D model into basically a computer game, if you will, because we are using Unity 3D, we can do a lot more than just visualize. We can actually visualize data, real-time data. We can help technicians do inspections. We can help with monitoring. We can help with safety and reducing risks by showing live data overlaid onto 3D models. And so we are working with the US government. We're working with public sector, private companies, portfolios of buildings, which is trying to really get sense of the different data streams that they are getting from different sources, and make sure that it's visible really on a mobile device and a handheld device.
Great, Carl Pucci, why don't you explain right off the bat what EO59 is? You're based in Estonia, but I know you've just gotten back from the United States. What is it? How did you come to form your company, and how does it fit into this concept of the digital twin for critical infrastructure?
Yeah, so our company EO is Earth observation, and the 59 is for the 59th degree of latitude, where I sit usually, and my desk is at 59.00000, which is pretty weird to be at such a zero latitude line. It's kind of clever. And what we're working with is this actually one of the very first Earth observation techniques in human history. In 1964, before anyone even went to the moon, there was this invention of a system called synthetic aperture radar. And the idea was, oh my gosh, can we see at night and through the clouds? We're all familiar with Google Maps and the optical imagery that we see there all the time. Well, that doesn't work very well if it's cloudy or if it's dark. So military intelligence agencies got into this business of looking at the Earth with radar. And so America and the Soviet Union got into this crazy race, and the stories were pretty wild. Space stations with cannons on them, and nuclear-powered radar equipment, which crashed into the Canadian Arctic and polluted the world. You can Google Rorset and find all kinds of weird. It's like a James Bond movie, right? And so my career was in government tech. And when I found out about this system, at first I was like, that's crazy. I mean, there's no way. I mean, what is that, right? And then I got more into it, and I realized, my God, the world around us is really in motion all the time. And that's something that I wasn't quite, aware of as a person who sits in a building. You don't feel like the building's moving, but actually all of our structures are moving constantly. And this synthetic aperture radar looks at the same structure, every time it overflies. So let's say that's, could be as frequently as daily or biweekly. And it takes, a picture of your building, and then it compares the phase of the radar when it left the spacecraft and when it returns, and then can see this sub-wavelength motion. So that's actually millimeter deformation on a target, right? And if we're talking about a digital twin, this is the only technique in the world that allows you to really go back in time and look at something that you didn't know you wanted to look at. So it would allow you to go back and access an archive of radar data of any structure or surface on planet Earth and look at the millimeter changes in that structure or surface, and then display that in a visualization system like a digital twin, where you have other data sets coming in, right? Or augmented reality, where you can actually walk the site and see that deformation trend in history at the same time. And so our industry is actually kind of weird in that it's one of the oldest techniques, but one that people haven't heard of. Everyone's heard of GPS, but who's heard of INSAR, right? And that's maybe the fault of the fact that it's so scientific and that it's been really funded by spooky people forever, right? So it kind of has this allure of like mystery and black magic to it, but it's not black magic. I mean, it actually works, and it works reliably well and at high accuracy, and there's thousands of papers written about it. But our job at EO59 is to work with people like Martin and with our clients to actually find a way to make this easier to understand and actionable, and not just an opaque data set sits in a corner and says, oh, hey, that building moved, 5 centimeters in the last year. What does that mean? I don't know what that means. But I mean, there's actually a whole series of meanings behind that, and that's what we are trying to do together.
Martin, the reason that's is important is because if a building moves by 5 millimeters, or if a bridge shifts in some way, that 5 millimeters may not be very much, but if that's part of a trend, then essentially what we're talking about is the potential for that there's some sort of deformation within the structure itself. And really what you guys are doing is helping the people who take care of and monitor these things to make sure that these structures are structurally sound, and it's all in the name of avoiding disaster. Is that a fair way of saying it?
Yeah, that's very precise. So if you think about it, we are all about interpretation of data. So we really very much enjoy working with Carl and his team because they've got a wonderful technology. And you will see shortly lots of data points that they are able to gather and collect on structures. We, on top of that, add as well operational data from sensors. So that adds another layer. We can also connect cameras. We can connect AI, which is then reading the camera imagery and is alerting to certain events that might be of interest operationally. And most importantly, we really are able to set up, alerts and visually allude to a certain event that is happening. So when you are an operation personnel, if you're responsible for running the facility, if you're responsible for coming and very quickly helping with something, an issue, an event which has occurred, you know where to go. So it's all about this spatial awareness, which we show the data in the context of the space of the digital twin, really.
Okay, Carl, maybe you could just describe how did you come to form to become involved with Ocular and to grow this into the type of alliance that you guys are now talking about forming. How did this happen? How did you guys meet?
Well, we can thank the coronavirus for that. So some good things came from
Yeah.
the corona experience. The European Union put together this, the EU hacks the virus hackathon. And, we were really focused on the infrastructure responding to coronavirus. Everyone's been focusing on the vaccinations and the testing and so on. That was really the core mission of that hackathon. But we were saying, my God, what about the hospitals, which are now completely overwhelmed? Are they structurally sound? And are they, how can we know that in a central way, across the European Union and investigate them quickly? So we did an assessment of a hospital, and then we worked together with Ocular to put that into AR so that they could actually, walk up to the hospital in Central Europe and look at it in a camera feed and see which sections of the structure had moved, to which extent over what period of time. It was a rate of deformation. So we know which parts of the structure were weaker than others. And, unfortunately, I don't feel like very many people paid attention to the product that we created. And then all of a sudden there was, unfortunately, this earthquake in Croatia, which destroyed a Croatian hospital, which is a horrible tragedy in the middle of the crisis. And then suddenly there was an interest in the infrastructure that's responding to coronavirus. And I think that since Corona has played out to be much longer than a few months long, now we're into this, basically endless cycle of pandemic. That infrastructure is more and more critical to pay attention to. So that's how we started collaborating, and that's grown from there.
Yep. And so from there, we started looking at different types of infrastructure that Carl and our partners from Schnabel Engineering and Synthetic have experience with. So we started working with airports, for instance. One example would be the Jaeger Airport in West Virginia that we discussed in the previous webinar. So we're going to show you some of the data from that airport specifically, where it's a very peculiar situation where you got the runway, which is at the edge of a hill. There was been a landslide; it needed to be reinforced. So there's a lot of structural. Heavy structural engineering that needed to be in place, including anchoring. And so we are using both the satellite data and the augmented reality and digital twins, where we can actually put in sensors to different anchors, which can read real time or even weekly data, and you can just inspect it remotely.
Okay. Martin, maybe you could explain what your system actually, what function it performs in this product that you guys are putting out. You're somewhere between an operating system and an user interface. How would you? But that's probably not describing it. It's not doing it justice. How would you describe it?
Well, it's actually, I think that is correct. I mean, we are just a user interface. We are purely helping to understand the data. All the complexity is in Carl's system and in the actual systems that are installed on site. The problem is that all of these intelligent systems that are installed and that give data, they're not that easily readable and they're not that easily understandable. And that's where we come in, because we simply show the data on the 3D model.
It seems to me that one of the other the value of what you're bringing is you're bringing all these different types of information and you're putting them into a single a single screen essentially that can be used to monitor these things. Maybe it would help to give an idea for what one of these components, what Carl's doing, what it actually looks like and what you're able to help visualize. Carl, are you set up right now to?
Yep, absolutely. I'd love to share my screen. So let me do that, and our colleague will enable it to be seen. So hold on one second here. All right, Robert, can you see that?
I can indeed.
Okay, so this is the Jaeger Airport in Charleston, West Virginia, and you can see lots of dots all over the place because our technique at EO59 uses natural scatter. So it's kind of like turning on the sensors from all around you without needing them. So all this data is coming without there being any actual device installed anywhere. They're colored for the historic time from deformation. So red is away from the satellite and blue is towards it. But this is really where Schnabel engineering is critically important, because we need them to interpret what we are seeing. But this object here at the end, this is actually the retaining wall that Schnabel built and replaced to work on Jaeger Airport and get it back in full condition. And here's a time series you can see where we can see every other week how each little component of the surface moved millimeter by millimeter at a time. And this is what is being connected to the Ocular system, which is, I believe, Martin, actually able to read the load cells and other interesting sensors which are in this wall as well.
So those
Exactly.
are all those data points. Those are all natural data points. Those are not referring to any sensors that are actually that have been put in there. Is that
That's
right?
right. That's all natural data. All natural data, like all natural chicken. Yeah, it's all natural, organic data that isn't coming from any particular sensor. It is the natural reflectivity of the Earth. Now there are some interesting devices that we can install called reflectors, which reflect back to the satellite, so you could see an area where, like this grassy area, which has no reflection, that could be installed there. And that's something that we've developed with a QR code on it that can launch the Ocular application and actually anchor the augmented reality view, so that you can walk around using the INSAR reflector as a base point and inspect the site.
And the point is that every time the satellite goes over this location, it's looking for every single one of those points, and it can then tell you if it has moved. Is that right?
Right. We actually don't pick these points at all. Our algorithm, our system, SARPROS, it picks these points automatically based on the quality threshold that we set. And we don't review them. Schnabel reviews them as the engineer on site. So it's critical that partnership is in place, and Schnabel is well trained, and they are truly the experts in their field at actually being able to drive meaning and reporting to the client, to the airport authority.
So in a sense, then you're the eyes, Schnabel is the brain that sort of assembles and does something with that information.
Right. I mean, you can think of us kind of like a film lab, right? So the satellite's flying around taking pictures on film. We develop the film, right, into a picture. We make the development chemicals and we develop the picture, and we sell the print to Schnabel, which then tells the client what the picture means.
Now, Martin, am I correct in saying that in addition to this, Schnabel has a bunch of monitoring within that actual structure? For example, that retaining wall, which is a huge thing and was absolutely critical to allowing that to allowing the airport to continue to function. They have a bunch of sensors basically embedded into that, and they also are monitoring that, and that is also monitored through that system that you're sort of helping to visualize and give the people who operate that infrastructure, operate that airport, so they can monitor it and make sure it's structural integrity.
Yeah, no, that's exactly right. So basically, on top of this, we're overlaying additional sensor data and operational data of the whole facility and cameras. So with the Jaeger Airport, we're just doing sensor data, but with other projects, we're also adding, for instance, Blue Force tracking. So we're able to see where the security personnel actually is on site. Should anything happen, you need to be able to locate them. You can see where they're moving during the incident. As Carl said, you can go on site and you can just read a QR code, and you can get access to all of the data through augmented reality. So it's like a digital panel which shows you where what is the actual status of that piece of infrastructure at that very moment. And you can also scroll and go down and look at the historical data, because Carl's system actually saves that. So that's for the satellite data, but also we keep in the database the data of all of the sensors, similarly as you see on the screen just now. Also, we do this in virtual reality. So if you are not on site, but you would like to see all of the sensors and you would just like to fly through, you are able to do that. And you have like an infotainment panel which you can spawn with your controller, and you see all of the data that you're interested in. So what you see right now is Carl basically browsing through his screen on his laptop. But the other ways of doing this is really just doing it in VR.
Yep.
So that's how they do inspections, and with not just the satellite data but all the other data, or AR, or just doing it on your phone or tablet.
And just how important this is, I think, for anybody who doesn't know, am I correct in saying that this Jaeger had to go in and do all this because the original wall collapsed? There was a huge I think a land shift, like a landslide,
Yep.
that there's no way to know exactly, for sure. But the idea is now that came as a surprise because it wasn't possible to predict it in the past. And the idea now is that while anything can happen at any time, usually these types of accidents or disasters happen for multiple reasons. There's several things that fall, but also there's so many different ways in which you guys are now monitoring that particular structure, that should give a far better chance of anticipating and taking corrective measures.
I think that, it's absolutely correct that it's about, monitoring something and preventing disaster. But there's another element to this, which is design, right? And knowing this information in advance of designing the next, corrective measure or another structure. If you have a digital twin of Jaeger Airport, which you have today with tons of data, I mean, the airport is not only that retention wall. It is all kinds of other stuff, right?
Yeah.
And now there's so much data there that if that airport authority were to build an extension to the runway the other direction, or to extend another terminal or something like this, then they have information that would influence Schnabel or other engineers' design of those structures. So our work with EO59 and Ocular can be present in all the stages of a design, build, maintain, renovate cycle, and I think that it's a new technique to be able to do this in a digital twin and with AR, using technology that's been around since the 60s. It was a James Bond kind of thing, and now the opportunity is really out there for people to leverage it. And the terrible thing is when you don't leverage it, right? So there's a lot of catastrophes that do happen in the world, unfortunately, where this data could have been, informative prior to that, or informative in the design phase.
I mean, sort of on that topic, Carl, I noticed that you were actually quoted in the Washington Post because you've become involved in the Surfside disaster. Obviously, this type of technology that you guys are doing right now is being used more in situations where there's critical infrastructure, in part because they require certain types of reporting, and is part of like how these things get managed. But I mean, just explain maybe quickly, because we don't have so much time. I mean, how have you become involved in that, and how that's an example of what you can be doing in cases of critical infrastructure?
Well, large condo towers where there's hundreds of lives at risk, could be considered critical infrastructure on their own, and some definitions. So, in the case of the Champlain Tower South failure in Florida just recently, which is a horrific tragedy, we were contacted by the town shortly after the failure for information on what had happened to the structure prior to the failure. Right. So our case for being engaged was to help determine the cause of failure, and also to help them assess the neighboring structures. So that's certainly something that we would aim to do proactively together with Ocular on similar projects in the future. Would be to work with towns or cities, for instance, imagine New York City or Chicago, LA, places where there are different levels of risk to aging infrastructure, and actually help them assess those buildings and do site inspections. I mean, imagine if you're a site inspector and you have our data of every single condo high-rise structure in a block of a dense city, and you can walk around with your camera phone, pointing at the tower and say, well, where the hell in this tower has there been this deformation? Here, click it, see the deformation, walk over to it, and look, has there been spalling? Is there rusted rebar? What is the fatigue of the building? Because now instead of sitting at my laptop at Starbucks trying to figure out where the hell this red dot is or the arrow for the load on the structure, I can load up the Ocular app and see EO59's data on site.
I should say, for anybody in the audience, we are open to questions. I think you can put it into the chat function. Martin, do you see that as a potential direction forward for you guys? And would you be looking to? It's probably not realistic to go building by building in terms of apartment buildings, but I could see this being something of a municipal mandate, something on the town level that could be in everybody's interest. Basically, is that realistic, or is that?
Eventually. I think this is a longer shot. The truth is, as Carl said, I mean, more and more infrastructures are becoming critical and are actually using this technology and this approach. So we have discussions after working with a number of governments and public sector clients. We started working with large real estate investment trusts, which have hundreds of buildings in their portfolios. So, and that is for them to improve their operational efficiency, and obviously also public safety around and in their buildings. So I see that it's going that way, definitely. While we are waiting to get questions, I was actually, because I'm sorry, I had everything prepared on my phone to show from the augmented reality perspective, the airport and everything. But then we figured out that this tool doesn't support sharing from the phone. So, and there is no way to show AR on a computer. What I can do is I can show some of the deployments of AR that we've done to help engineering, to help inspections, to help basically understanding of the data and the structure itself. So let me just share my screen here. Okay. So this is something that we prepared for Expo in Dubai. And showing the different ways of using AR. So basically, going through the interior, you are able to, once you have the 3D model, you are able to very quickly understand the impact of rehabs and the impact of your structure. So this is a logistics park, for instance, where we have justification of different sustainability investments. Yeah, as an example. So what I'm showing is that it's really, as you are now able to digitize pretty much everything and very, very quickly and bring the cost down, it's not unrealistic that you can start using this technology and get the data and get the understanding of the data to your clients, to your tenants, to your stakeholders, and obviously, most importantly, for safety purposes. And so here is an example of a digital twin with an explosion, which is simulated here, and the impact of that explosion on the structural integrity of a refinery site, for instance. So that's another piece of critical infrastructure where we've used this technology.
Robert, you're muted.
Sorry, I could see that being a very critical thing for first responders to have access to that type of information.
Definitely.
So we have a
Definitely.
question here, which is, are these products capable to analyze the data and identify what could be the source of the problem in the structure? Thank you, Reza.
Yeah, that's exactly what we're doing in the Champlain Tower South case. I mean, imagine you have a structure that has a known issue of some kind, whether it's that refinery or case or another one. You want to see where there's been historic deformation, right? I mean, structures are moving all the time, but if you understand their capacity for motion, you can see how much they've moved in the past 10 years. That can be instrumental in your analysis as an engineer to identify what could be the source of the problem.
I mean, from what you guys are saying as well, I mean, it's not the actual instruments, it's not an algorithm that figures out exactly what the source of the problem is, but it's taking that data, and Schnabel with its engineering information is able to analyze what's happening and come up with hypotheses that they can then test out to check further about what it would be.
Yep.
Okay, we have possibly just a comment here. Very cool use of augmented reality technology, data analytics, and predictive analysis. Well, that sounds like basically a compliment for you guys. Thank you, Matt, for your comment.
Thanks, Matt.
One question I would wonder is there growing sort of pressure from insurance companies to make this part of their policies? Are they starting to demand it or give better rates for structures that include this type of monitoring?
Yeah, very much so. Especially where you have large portfolios of important assets, such as airports or
Right.
ports or dams, and you are reaching the limits of the insurance, and you basically need to reduce those by assessing the risk better, and by taking precautions, and our way of basically turning every critical asset into a computer game, and enabling the personnel to very quickly respond to an incident is reducing that risk. So yeah, we have discussions with a number of insurance companies on this.
And also not just reducing the risk, but adequately pricing the risk, because
Exactly.
a lot of
knowing the risk.
Yeah, and if you're going to invest in a structure, you might want to know how much the thing's moved. Like Millennium Tower in San Francisco is like falling over. I mean, so it's an interesting proposition to a large scale investor or insurer.
Well, certainly, because an insurer, the fewer unknown unknowns there are out there, the better, the more accurately, the more efficiently they can calculate and cover or underwrite that particular risk. So.
Yep, it's a innovation is tricky, and it's a process and painful one at that. Insurers are very used to getting oodles of data for 20 cents a structure or something. So there is a method to going together with our companies and discussing and learning and figuring out how to fit these economic models, and doing things differently is not just a plug and play activity like a Lego block. I mean, it does take time. And I think that is really one of the specialties of our companies. There's a lot of businesses offering these services, but how do you think? How do you approach those problems? Do we understand the issues that our clients really are facing and implementing this and understanding it? I think that's our strength.
Okay, we have another question from Robert Boylev. I'm sorry if I murdered the pronunciation on that, but can you share some quantification metrics for risk assessment? Is someone going to have a crack at that one? In other words, avoided cost, business interruption avoidance.
Yeah. So not holistically. We are at the beginning of the conversations with the insurers, and we do have some analysis. I'll give just one example to speak for all. When we were testing this on a search and rescue operation in a stadium where we would have a complete digital twin with live sensors and visibility of people movement, we were able to improve the time of a standard search and rescue from 10 minutes to 2.5 minutes, right? So that can give you just an example, really, on how just visibility of what's going on. Such a small thing, you would think, right? But that interactivity, that visibility empowers you to reduce the time by order of magnitude. And that can be applied to different scenarios, such as, avoiding interruption time and cost, and being able to quickly fix something if there's an incident, critical incident, being able to respond, being able to predict it even. So there's wide variety of things that you can do, and we are really just assisting this. I mean, as Carl said, a lot of companies are offering lots of services in this space, but nobody has really figured out yet how to make everything digital and accessible, and have the right information accessible at the right time. So we're just doing our little part in that, and I think in the next couple of decades we will see a lot more of this.
It's a little part with a big impact. I mean, think about if you could see how much a bridge deformed without having to close traffic on the bridge and then actually install sensors, right? And closing traffic to a large structure going into a major city can cost an economy a fortune. Or shutting down an airport to repair a runway. I mean, the cost of operations for the airport is humongous. But I can give you a specific example. We have a client that's a large dam. They are dewatering the reservoir in the dam. And by dewatering the reservoir, the houses built around the sides are moving, right? And they moved each time the reservoir is dewatered. Well, these homeowners would love it if you'd buy their houses. Each one of those houses is worth $5 million. Well, if the operator of the dam can say, well, I mean, your house has not moved, man. I mean, I could see it from the satellite. It's not moving. I'm not buying your house. So they literally have saved a fortune from having to not buy all this property, and not have to do inspections and actually look at foundations, because they can see all the deformation of all those structures from their laptop.
We had another question there. Excellent application. How does the pricing model work? So that's really cutting down to the core of things, isn't it?
Yep. So from our standpoint, it's really per square foot for the digitization of the asset. If the asset is already digitized, that brings the price down and the time to actually create the digital twin down. And then there is a maintenance fee depending on the number of integrations and the number of data that you are streaming to our cloud and to your mobile application, really.
And for INSAR data, it's similar. Our pricing is decided on the size of the target that we're looking at, the complexity of what you're trying to see. And we really have two prices. We have this price to go back in time, and then this forward monitoring of an asset. And that is something that we really decide in close conversation with intermediary engineering firm, typically, about what is the goal of that observation, what is it we're trying to achieve, what is the right satellite for the job. And that's something that we do in conversation.
Right. Okay, that's great stuff. We have another one. Comment from Alan. This compilation of data helps stakeholders with cognition of the very complicated systems, often making prioritization of decision making easier. That's it. Thank you, Alan, for that.
Yeah.
I think it's important to say that there's other people, there's other components for this system. There's also Tim Brewer, who works at Synthetic, who's able to bring expertise in potential for example, explosions that could happen within a particular structure. Their know-how is understanding essentially the physics of an explosion and the impact that would have on the given structure. So that again is planning for a worst case scenario, but also, Carl, as you were saying, potentially helping in the design of structures to make sure they're built to withstand that type of an event.
Yeah, and to Alan's comment, I mean, if you have a city like Miami or San Juan, Puerto Rico gets hit by an earthquake or a hurricane, I mean, it's difficult to find a more rapid disaster assessment and impact system, because this satellite technique can see through the hurricane, so it sees through clouds, and you can see those structures actually changing in the event itself. Now, we're not very good at rapid failures, sudden, spontaneous, just, explosion. But at these things which can be predicted and seeing what was pre-existing problems, what problems were caused by the event, and what is a hidden problem. It's easy to see a destroyed building. It's hard to see a cracked foundation that's going to be leaking water for the next 20 years.
Yeah. And Carl, your data goes back potentially how far?
To 1992.
Okay, right. So that's significant.
Nice.
Okay, well, we're at about 40 minutes now. We promised people it would be about half an hour. If there's no other, there's no final questions out there, and I don't see them, guys, I think it's probably time to wrap this up.
Thank everybody for for participating today and for listening to us, and I hope that we have a chance to connect again in the future as a team. Martin, thank you very much for having us, and Robert for being such a fantastic host. I think this is very, very, very informative for all of our user groups.
Great. And anybody interested, I assume, Martin, they can contact you or Carl,
Yep.
either of them, if you have further, if you'd like to take this offline or have subsequent discussions. They're both of them are very open to that.
LinkedIn.
There you go.
Exactly.
Okay. Great. Thanks a lot, guys. Martin, Carl.
Thank you very much.
Talking to you guys. Okay. So,
Take
bye,
care, everyone.
everybody. Thank you.